Amir. Hello, good afternoon. Am I audible? Are you able to hear my voice? Good afternoon. Now, yesterday we have started the maxima and minima topic. In the maxima and minima topic, already we have seen the how to find the maximum minimum for one variable function and how to find the maximum minimum of two variable function. We have written the procedure, and after the procedure we have started the problems. Now we do the continuance of the problems. Yesterday we have completed the 3 problems, I think. One, two, three. So we have completed 3 problems. Next, continuation of the problems. Problem number 4. Now, today's class. The maximum value of the determinant among all 2 by 2 real symmetric matrices with trace 10 is. It is a 2 marks gate question on that. It is a 2 marks gate question. In the first 3 problems, directly the function was given. It was asked to write the pointer maximum value of the function in the interval like that. But here we are not given the function directly only. The maximum value of the determinant among all 2 by 2 real symmetric matrices with a trace 10 only. We require the maximum value of the determinant. Maximum value of the determinant. That is maximum value of the function. Just like previous problems, the maximum value of the function. In place of function, what do we have here? Determinant. So our determinant is the function only. In the first 3 problems, function was given directly. Here, the function is not given. First, we have to construct the function. After constructing the function, according to given data, then we try to find the maximum value of that function. That function is same as determinant here. It is a 2 marks gate question. Now, just first we'll discuss about this problem. Among all 2 by 2 real symmetric matrices, 2 by 2 symmetric matrix, that is real only. All the elements in the matrix should be real only. First of all, the general form of 2 by 2 matrix is A, B, C, D. Or we can take the X, Y, Z, or like this. Anyone we can take. Let us take the X, Y, Z, R. It is a 2 by general form of 2 by 2 matrix only. Let us suppose X, Y, Z, R are real elements. So it is a real matrix only. Next, we require the symmetric matrix. The condition for symmetric matrix is Aij equal to Aji, I comma jth element equal to j comma ith element only, or A transpose equal to A only. This is A12, this is A21. These two should be same only. A12 equal to A21 only. These two should be same only. So according to symmetric matrix, the condition is if it is Y, this should be Y. And this is X. Let us suppose this is Z on. Right? It is a symmetric matrix on. Let us suppose this matrix is A. It is a real symmetric matrix. Next, determinant. We are asked to find the maximum value of the determinant. Determinant is our function. Maximum value of the function. Maximum value of the function. In place of function, what do you have? Determinant. So determinant is our function. Let us suppose determinant is determinant equal to xz minus y square. We take this as function of xyz, but it is a function of 3 variables. Actually, we have written the 2 methods for maximum minimum. One method is for 1 variable, one other method is for 2 variable. And we did not write any method for 3 variable function. If it is possible to reduce this 3 variable to 1 variable or 2 variable, then we can find the maximum value of this determinant only. And we are given some condition here. What is the condition here? Trace. Real symmetric matrix with a trace 10 only. With a trace 10. Trace means sum of the diagonal elements of the matrix. Here, sum of the diagonal elements is x plus z. This is a trace only. Already it is given the 10. So with this given trace, we try to convert this 3 variable to 2 variable. We can express x in terms of z, or we can express z in terms of x anyone. From this, if I write the z equal to 10 minus x, then x into 10 minus x minus y square. So that we get the 2 variable function only. Now here onwards, we follow our same method only. According to given data, we have written the function like this. Determinant is our function. We have to maximize this function. Right? It is a problem. So we are asked to find the maximum value of this determinant among all 2 by 2 real symmetric matrices with the trace 10 only. Right? Okay, let us do the problem. Let capital A equal to 2 by 2 matrix with elements x, y, y, z be the 2 by 2 real symmetric matrix such that trace equal to 10. That is x plus z equal to 10. Then determinant of A equal to xz minus y square. Now from this given condition x plus z equal to 10, we replace z with 10 minus x only. This is equal to x into 10 minus x minus y square. This is our determinant. We have to maximize this only. We have to find the maximum value of this determinant. That is the maximum value of this function only. So let us take the f of x comma y equal to determinant of A equal to 10x minus x square minus y square. Here onwards, we follow our method only because f of x comma y is function of 2 variables only. Already we know the method of finding the maximum of 2 variable function. According to our procedure, first we have to find the first order and second order partial derivatives. P equal to fx equal to, with respect to x partially, 10 minus 2x, comma, q equal to fy equal to 0, 0 minus 2y. Just observe the P and Q functions. P is a linear function, Q is a linear function. And if we equate both to 0 and if we solve for x and y, we get only one stationary point because we'll get only one value for x, one value for y. So we'll get the one stationary point. If you get only one stationary point, you need not to check the RT minus S square condition is greater than 0, less than 0 or equal to 0 because already it is a maximization problem. Directly we are asked to find the maximum value only. So if we get only one stationary point, don't find the second order derivatives, directly take this as stationary point as maximum point and then write the maximum value only. Because it is already maximization problem. In the question itself, we are asked to find the maximum value only with the condition. And also this type of problem is called conditional maximum or constraint maximum only because we are given the function along with the trace condition only. Consider small p equal to 0 and small q equal to 0 only, which implies p equal to 10 minus 2x equal to 0 and q minus 2y equal to 0, which implies x equal to 5 comma y equal to 0. Therefore, x comma y equal to 5 comma 0 is a stationary point. And it is a maximum point because only one stationary point only. So directly we can add the maximum value of this function. Hence, even if you find second order derivatives and if you verify the condition also, we get the same thing because fxx is minus 2, fyy is minus 2, product is plus 4, and fxy is 0, rt minus s square is greater than 0. Rt minus s square greater than 0 means either maybe max or minimum, but r will be minus 2 negative. Negative means that is positive only. So directly it is maximum point only. Hence, the maximum value of the determinant of a 2 by 2 matrix is determinant of a equal to f of at what point 5 comma 0 5 comma 0. Now here determinant is 10x minus x square minus y square only. X equal to 5 and y equal to 0 only. 10 into 5 minus 5 square minus 0 square. This is equal to 50 minus 25, 25. This is the answer. So it is a 2 marks gate question. Yesterday's last class, that problem was lengthy only, but this is very simple only, even though it is 2 variable function. Whether you have observed or not, the previous problem is a lengthy problem only. That is because of the more than 2 stationary points only. If you get only 1, 2 stationary points, no problem. If you get more than 2 stationary points, 3, 4, 5 like this, then it will be lengthy only. Because of lengthy for 2 variable function maximum minimum problems, we have very few gate questions on 2 variable. Most of the gate questions from 1 variable function maximum minimum. That too function along with the interval. Function along with interval means global maximum only or global minimum only. Right? This is the 4th problem. Next, we are at the problem number 5. The maximum area in square units of a rectangle whose vertices lie on the ellipse. X square plus 4y square equal to 1 is. It is also 2 marks gate question. The previous one is 2 marks gate question. It is also 2 marks gate question. Yesterday's first problem is the IES question. The previous problem, just now whatever we have done the problem, that is a fill in the blank question. It is also fill in the blank question. So 4 and 5 are 2 marks gate questions. Now we write the solution. Now before writing the solution, just look at this. Like fourth problem, here also no function. Function was not given. In the fourth problem, function was not given. Here also function is not given only. The maximum area, that is maximum value of area is required. Of which object? Rectangle only. The maximum value of area. Just like in the previous problem, maximum value of the determinant. Here maximum value of area. Maximum value of area only. Maximum value of the function. Maximum value of the function. In place of function, what do you have here? Area. Area is our function. In the previous problem, maximum value of the determinant is required. Maximum value of the determinant, that is maximum value of the function in place of function determinant in the last problem. But here maximum value of area means area is our function. Area of which object? Rectangle only. And the condition. For rectangle, all the 4 vertices lie on the ellipse. Again, it is also conditional maximum minimum problem or constrained maximum minimum problem, like previous one only. Here also function is not given. We choose the function as area only. And then we have to maximize this. Here like this one. Ellipse is given. And the equation of the ellipse is x square plus 4y square equal to 1, or x square by 1 square plus y square by 1 by 2 square. It is a given ellipse only. And it is a standard form. X square by a square plus y square by b square equal to 1. A is 1 greater than b equal to 1 by 2 only. So major axis is x-axis, minor axis is y-axis only. X-axis, y-axis. And we have to take the rectangle because all the vertices of rectangle lie on the ellipse only. So rectangle should be inside the ellipse only. But the condition is all the vertices should lie on ellipse. It is a condition. Like this. It is the origin. And this point is a coordinate of a point. And this coordinate point on the curve is the vertex, one of the vertex of the rectangle. Let us suppose this length is x. Here to here, x on. And this height is here to here, this height is y. Then this point will be, this vertex will be x comma y only. General vertex x comma y. Because we don't know the exact length, this length. Here to here, this distance we don't know. This distance is we don't know. So general length, this is x, because it is along the x-axis, we are taking this as x, and this as along the y-axis. So we consider this distance as, or this height as y. So this x, y together, this is a coordinate of a point. This coordinate of a point on the curve is the one of the vertex of this rectangle only, right? General vertex only. Suppose if we take this is the x length, then this should be x only. Here we have taken this as x. This is x means because it is symmetric about x-axis, y-axis, this figure is. That is why this length is x, this length will be x. This length is y, or this height is y. This height is also y only. Next, we have to write the area. If this is x, this is x. From here to here, the length is 2x. From here to here, this height is y plus y, 2y. So area is this rectangle, length is 2x. This side 2y, finally 2x into 2y. And don't think that this is a rectangle, area is x into y. Because it is not, we are not taking only the rectangle. We are given condition. All the vertices should lie on the curve only. That's why we should take only like this only, not like this. Right? Here this area is xy only, but here area is 2x into 2y. Finally, it is a 4xy. We have to maximize this only, right? Have to find the maximum value of this. Finding the maximum value of this area is same as they find the maximum value of this function. This function is in terms of two variables, but we are given condition. What is the condition? For this rectangle, vertex is lying on the ellipse only. Because of this condition, we use this equation of the ellipse and we can convert this two variable to one variable also. So from this, we can write the x square in terms of y or y square in terms of y square in terms of x only. Let us write the y square in terms of x so that we get this function in terms of x only, because we are habituated with the function of x only. So y square equal to 1 minus x square divided by 4, or y equal to plus or minus 1 by 2 into under root of 1 minus x square. This is the y only. If I substitute here 4 into x into plus or minus 1 by 2 under root of 1 minus x square. Right? But we are taking the area, so let us take the plus only. Now this is under root of 1 by 2 under root of 1 minus x square. Now this is our function. We can, here onwards we can follow the one variable function. Here onwards we can follow the one variable function. But in the product of these two terms, this is simple term, but this is containing the root only. So to find the maximum value of the area, we should find the first derivative and second derivative. First derivative and second derivative. If we have only x square, x cube like this, in easy way we can find the first order, second order derivatives only. Because of root, it will take more time. So to reduce this complexity, to avoid this root, in easy way to find the derivatives, let us consider this function as other form like this. Because a is maximum, then a square will be also maximum only. If a is maximum, a square will be maximum. Let us suppose a is 2. If it is maximum, a square will be also maximum only. 2 square, that is 4. That is why let us take the function as a square equal to 4x square into 4y square. Because of 4y square, directly we can replace the 4y square with 1 minus x square only. 4x square into 1 minus x square. Here no root. In easy way we can find the derivatives. If you take whatever you choose, no problem. If you choose this one, this function will involve the root only. And if you choose this function, it doesn't involve the root. So that in easy way we can find the derivatives and we can do the problem only. So let us take this. It is the reason only. Otherwise we can take this and we can verify also. No problem. Okay, let us do the problem. No, we are doing the problem in the solution. Let 2x and 2y be the length and breadth of a rectangle whose vertices lie on the ellipse. X square plus 4y square equal to 1 only. So for our, according to given data with the condition, it is a rectangle. For this rectangle, one side is 2x, other side is 2y. So length is 2x, breadth is 2y. From these two, we can add the area. Then the area of the rectangle is a equal to 2x into 2y. Area of the rectangle is a equal to 2x into 2y, which implies we are not taking this as area, we are taking the a square, an easy way to do the problem to avoid the square roots for finding the derivatives of the function, which implies a square equal to 4x square into 4y square. This is equal to 4x square into, from this equation of the ellipse, we are writing the 4y square as 1 minus x square. So let us choose this function as our function. Let f of x equal to a square equal to 4x square minus 4 into x power 4. So it is a one variable function. Here onwards we follow the one variable method max minimum. Then f dash of x equal to 8x minus 16x cube, and f double dash of x equal to 8 minus 48x square. After this, consider first derivative 2 equal to 0 to find the trace points, which implies 8x is common. 8x into 1 minus 2x square equal to 0. Therefore, x equal to 0, comma, x equal to plus or minus 1 by root 2 plus or minus 1 by root 2 are the stationary points. So here we got three stationary points: 0, plus 1 by 2, plus 1 by root 2, minus 1 by root 2. But 0 is not possible because this length should not be 0. If the length is 0, we cannot get the rectangle on it. So x equal to 0 is not possible. Next, x equal to minus is also not possible here. Then we should take the side as positive value only. X equal to plus 1 by root 2 only. It is a possible value. At that point, f double dash of x is negative or positive, check it on. When you substitute plus 1 by root 2 here in place of x, already square is there. Root get cancelled, 1 by 2. 1 by 2 here, minus 24. Minus 24 plus 8, negative. So it is less than 0 means maximum only. So 1 by root is the point of maximum. Directly we can add the maximum value also. Or we can do this. At x equal to plus 1 by root 2, f double dash of 1 by root 2 equal to, the function is, what is the function here? 8 minus 48 x square. 8 minus 48 1 by root 2 square. 8 minus 2, 24. This is negative. So the function will have maximum. Therefore, x equal to 1 by root 2 is a point of maximum. Hence, the maximum value of the area of a rectangle is a equal to x into 2y. 2x into 2y equal to 2x into 2 into y in place of y, we write the 1 by 2 into under root of 1 minus x square, and x equal to 1 by 2, 1 by root 2 only. 2 get cancelled. 2 into x so this is under root of 1 minus 1 by 2, because x equal to 1 by root 2, and here x is also 2, 1 by root 2. Into 1 by root 2 is equal to 2 into 1 by 2. 1 by root 2 from this 1 by root 2, 1 by 2, 2 into 2, 1. Now this is the maximum value of the area of the rectangle with the given condition. Condition is the 4 vertices of rectangle are lying on the ellipse. This is the maximization problem, and it's also conditional problem or constraint problem, because some condition is given only in this and previous problem. So the last two problems, that is 4, 5 are constrained maximum minimum problems or conditional maximum minimum problems. And these two, 4, 5 are gate questions, both are 2 marks questions, and also both are fill in the blank questions or numerical type answer questions. Let us do the last problem for maximum minimum. Problem number 6. The range of values of k for which the function f of x equal to k square minus 4 into x square plus 6x x cube plus 8x power 4 has a local maxima at a point x equal to 0 is option A, k less than minus 2 or k greater than 2. Option B, k less than or equal to minus 2 or k greater than or equal to 2. Option C, minus 2 less than k less than 2 only. Option D, minus 2 less than or equal to k less than or equal to 2 only. This is a given function along with the point, and this point is local maximum only. And we are asked to find the k values only. The range of values of k, that is the set of values of k for which this function will have local maximum at this point only. That is for what values of k, in the function, the function will have local maximum at this point x equal to 0 only. So already local point of maximum is given, and use this point of maximum condition and find the values of k only. Already he is saying that maximum at x equal to 0 only, local maximum at equal. Whenever the function has maximum, definitely the first derivative is 0, and second derivative should be at this point 0. Maximum is it should be less than 0. With this condition, we can find the range of values of k only. So to have maximum at x equal to 0, the condition is f double dash of x less than 0 only. Use this condition, solve for k only. It is a fourth order polynomial only. If we find the second derivative, in this term, x will be there. In this term also x will be present. When you substitute x equals 0, after finding the second derivative, these two terms will become zeros. Only this will be left only. So from this we get the directly k values. Like that we can choose, or we can find the derivatives only. Okay, let us do this problem. Given f of x equal to k square minus 4 into x square plus 6x cube plus 8x power 4. It is a given function, which implies f dash of x equal to 2x into k square minus 4 plus 18x square plus 32x cube, and f double dash of x equal to 2 into k square minus 4 plus 36x plus 96x square. Already it is given that maximum, local maximum. The function is having local maximum. Consider f double dash of 0 less than 0 for local maximum. Already is given that maximum at a point x equals 0. That is why we are directly taking the f double dash of 0 less than 0, which implies it is f double dash function. When you substitute x equals 0, this is 0, and this is not equal to 0. So 2 into k square minus 4 less than 0. And if we simplify this, we get the values of k for which it will have maximum, which implies k minus 2 into k plus 2 less than 0. Therefore, minus 2 less than k less than 2 only. That is all the values of k between minus 2 plus 2, the function will have local maximum at x equals 0. Only the values of k between these two, only the values of k between these two, the function will have local maximum at x equals 0. Otherwise, it will not have local maximum. This is according to this one. X minus alpha into x minus beta less than 0 if and only if alpha less than x less than beta such that alpha less than beta. Right. Here alpha is minus 2 because minus 2 is less than the 2 only. K minus of minus 2 into k minus 2 less than 0, like this. That's all. With this, the problem is completed. With this problem, the maxima and minima topic is completed. That is, differential calculus part is completed. Now, till now, we have seen that the limits, continuity, differentiability, mean value theorems, Taylor and Maclaurin series, next partial and total derivatives, and then maximum minimum only. In the differential calculus part, one of the part is left, that is indeterminate forms, indeterminate problems. That is limits on the indeterminate forms only. So we complete that one. After that, we go to the integral calculus. Again, we are going back to the limit problems. Now we do the limit problems on indeterminate forms only. Indeterminate forms. And this is also required for integral calculus. It is also required for integral calculus. That is why before going to start the integral calculus, we are going to start the problems on indeterminate forms only. Without starting the problem directly, first we write the indeterminate form definition, and also we write the method of finding the value of the limit. Method of finding the value of the limit when the function is in indeterminate form. Indeterminate form. If f of x and g of x are any two functions, and f of a equal to 0, comma g of a equal to 0 at any point x equal to a, then the ratio of the form f of x by g of x takes the form f of x by g of x takes the form 0 by 0, and it is called an indeterminate form. It is also called meaningless form. This is also called meaningless form because just look at this. 2 by 4 equal to 1 by 2. Next, 2 by 0 equal to infinity. 0 by 2 equal to 0. 3 by infinity equal to 0. Next, 4 by 4 equal to 1. Next, 0 by 0 equal to, can we cancel these to 1 like this? No, this is not correct. 0 by 0. Now look at all these values. 2 by 4, 1 by 2, definite value. Something by 0, infinite, definite value. But here infinity means larger and larger value. Here 0 by something, 0, definite value. 3 by infinity, 0, definite value, definite value. We have some meaning, full value here. We have some meaning for each value only. Finite value or in larger value, infinite value. But here, no meaning for this only. So no meaning for this means meaningless form only. That is why this is called indeterminate form only. This is called indeterminate form or meaningless form only. Anything is reducible to 0 by 0, then such a form is also called. If any other form is reducible to 0 by 0, such a form is also called indeterminate form. You take some form and check whether that is reducible to 0 by 0 or not. If it is reducible, such a form is also called indeterminate form. Let us consider one form like this and we check whether it is reducible to 0 by 0 or not. Now, infinity into infinity. We check whether it is reducible to 0 by 0 or not. Now, to get something by something, I'm keeping this as same, just I'm shifting this first infinity to denominator. If I want to shift this a to denominator, we can add this as 1 divided by 1 by a. Or if it is like this, then 1 by b whole divided by 1 by a, like this. So 1 by infinity in the denominator. This is same. But something by infinity becomes 0. 1 by 0 into infinity. Not 0 by 0. Still we have to simplify this. 1 by 0. Again we shift the infinity to denominator. 1 by infinity. Again this is 0. In the denominator 0 into 0, 0. 1 by 0. 1 by 0 is infinity. So finally we got the infinite only. We have started with the infinity into infinity and we have reached this infinity only. Infinity into infinity is reduced to infinity only, not 0 by 0. Therefore, this is not a indeterminate form. It is not a meaningless form only. Right? Or we can add this as infinity square. So infinity square is infinity. Infinity cube is infinity. Infinity power 100 is infinity, like this one. This is not a indeterminate form. Now let us take the another form, infinity by infinity only. Again, we check whether it is reducible to 0 by 0 or not. If it is reducible to 0 by 0, then this is called indeterminate form or meaningless form. Right? Now we'll check this. Now I am keeping the one as fixed. The other one is, I am shifting the other one to denominator. Okay. Now I'm shifting this to numerator, 1 by infinity into infinity. This 1 by infinity is 0 into infinity. It is not 0 by 0. Still, I have to simplify. Again, I'm shifting this to denominator, 0. 1 by infinity is 0. That's, or simply here, this is 2 here, 0 by 0. So infinity by 0 by 0. So this is indeterminate form. So like this, anything is reducible to 0 by 0. Anything is reducible to 0 by 0. Such a form is also called indeterminate form. Like this, we have some other forms. We are the all other forms of this indeterminate form as a note point. Note point. Other indeterminate forms. Indeterminate forms or infinity by infinity, comma, 0 into infinity, comma, infinity minus infinity, comma, 0 power 0, infinity power 0, and 1 power infinity. These are the other forms of indeterminate forms. All these will be reduced to 0 by 0 form. Right? Later we do the problem so that you will know how to reduce these to 0 by 0 only. Next, while evaluating the limit, while doing the problem on limits, if we get any one of these, then we try to write the value of the limit using L'Hospital rule. While doing the problems on limits, if we get any one of these forms, 0 by 0, infinity by infinity, 0 into infinity, like this, any one of these form, we try to write the value of the limit by using the L'Hospital method or LH rule. So let us write the LH rule. If limit extends to a of f of x by g of x equal to 0 by 0 form, then limit extends to a of f of x by g of x. So if we get like this 0 by 0 form, according to this rule, differentiate numerator separately, denominator separately. It is something by something. Don't use division rule to differentiate this only. Don't use d by dx of u by v formula. Differentiate the numerator function f of x separately. Differentiate g of x function separately. Don't use this division rule only. Limit extends to a. The derivative of numerator function is, let us suppose, f dash of x. Derivative of denominator function is g dash of x. Now, after finding the derivatives, we get a new function here only. It is an old function. It is a new function. After getting the new function, we observe this function value at a point A. When you observe this function value at a point A, there are the four possibilities. The four possibilities are like this. Numerator is not equal to 0, denominator is 0. Or numerator is equal to 0, denominator is not equal to 0. Or numerator is not equal to 0, denominator is also not equal to 0. Or both numerator and denominators are 0. But this is the 0 by 0 form, that is indeterminate form. And these are the not indeterminate forms only. So if we get any one of these, here at a point A, then we stop and we write the value of the limit. Let us suppose this is not possible. Only one of this is possible. So we stop and we write this as f dash of A by g dash of A only. Right? So if it is 0 by 0 form, let us find the first derivatives. We get new function and we substitute A in place of x, and then we observe the values of this. And these are the possibilities. Out of three possibilities, out of the four possibilities, any one of these three possible, we stop, we write the value like this. Again, if we get this one, we cannot stop. We continue this process on. Again, if f dash of A equal to 0 equal to g dash of A, then limit extends to A of f of x by g of x equal to limit extends to A of f dash of x by g dash of x equal to limit extends to A of f double dash of x by g double dash of x on. So whenever f dash of A is 0, g dash of A is 0, this is 0 by 0 form. That is why we are going to next order derivative only. So here we get new function. Again, for this function, observe the value at this point A. If you observe this function value at this point A, these are the four possibilities only. Out of these four possibilities, one of these three possible, then we stop. We write this as f double dash of A divided by g double dash of A. Suppose if we get this one, we cannot stop here. We continue this process only. And so on. We continue this process as long as we obtain 0 by 0 form. If we get 0 by 0, continue this. 0 by 0, continue this. 0 by 0, continue this. Not 0 by 0, stop. That's all. So we continue this process as long as we obtain 0 by 0. This is L'Hospital rule. Next, we go to the problems. Problem number 1. Limit extends to 0 of x into sin x divided by 1 minus cos x. Already we have seen the two methods for the evaluation of limits of it. When function contains modulus function, function contains step function becomes infinite, or function is given in more than one interval, or condition for x is given in the function. Condition for x is given in the function. In these four cases, to find the limit of the function, we follow the definition method. That is, definition method means we should find left-hand limit, right-hand limit. We check whether they are same or not. LHL equal to RHL, we can say limit of the function is possible, and we write the value of the limit. Suppose the function is not involving these, then we go to the substitution method, direct substitution. Substitute the point A in the function, we write. Suppose the function is not in the form of these, then we observe this function value at a point. First of all, if a limit problem is given like this, check the function is containing modulus, step, function is becoming infinite, or function is given like this, or function is given along with the condition for x or not this. Then other two methods, direct substitution or L'Hospital method. But L'Hospital method is possible when like this forms only. 0 by 0, infinity by infinity, 0 into infinity, infinity minus infinity, 0 power 0, infinity power 0, 1 power infinity only. Whenever function is not like this, then check the function value is in the form of any one of these or not. Any one of these, use the L'Hospital method. Not in the form of this, not in the form of this, then direct substitution method. So 3 methods only. LHL equal to RHL method, that is definition method. Next, L'Hospital method, and then direct substitution only. 3 methods only, mainly. Now, we are given the limit of this function at a point 0. When you substitute x equals 0 here, first of all, this function is not containing the modulus, not containing the step function, and this is not becoming infinite also at a given point. And there is no condition for x in the given problem. For this function, condition for x is not given, not modulus, not this is not becoming infinite. It is not containing the step function also. So this doesn't belong to this only. And we check whether this is in the form of any one of these or not. At 0, sine 0, 0, x is 0, cos 0, 1, 1 minus 1, 0. Now this is in the form of 0 by 0 form. That is, this belongs to this only. So we follow the L'Hospital method. And also, remember one point, L'Hospital is designed for 0 by 0. But L'Hospital method can be applied very first two forms directly, other forms indirectly only. Actually, we have the L'Hospital rule only for 0 by 0, but we can apply the L'Hospital rule for infinity by infinity because infinity by infinity is reducible to 0 by 0 form. Other forms are also reducible to 0 by 0. So indirectly, we apply the L'Hospital rule for these forms only. For these two directly, we can apply only. Okay, let us do the problem. Limit x tends to 0 of x into sin x divided by 1 minus cos x equal to limit x tends to 0. Because of the 0 by 0 form, differentiate once in the numerator and denominator only. In the numerator, it is the product of two function. Use the product rule, UV rule only. X into derivative of sin is cos x plus sin x into x derivative is 1. So sin x divided by 0 minus plus sin x. Derivative of cos is minus sin x. Minus becomes plus 1. This is the first derivative. After finding the first derivatives, we have this new function only. After getting the new function, again observe this function value at a point 0. If it is not 0 by 0, directly write the value. If it is 0 by 0, once again differentiate. Now check this. At x equals 0, 0, x equals 0, sin 0, 0, x equals 0, sin 0, 0. Again it is 0 by 0 form. Because of 0 by 0 form, we cannot stop here. Once again, we differentiate only. That is, find the second order derivatives. Limit x tends to 0 of x into cos x, product of two functions, minus x into sin x plus cos x for the first function, plus sin x derivatives cos x. In the denominator, sin x derivatives cos x. Right? Now it is a new function. After getting the new function like this, again observe this total function value at 0. 0, cos 0, 1, cos 0, 1, 1 plus 1, 2, 2 plus 0, 2. Numerator is not becoming 0. Therefore, it is not 0 by 0. Directly write the value of the limit. Don't find the next order derivative. Stop here, write the value on. This is equal to 0 plus 1 plus 1 divided by 1 equal to 2 only. That's it. This is the first problem. Next, problem number 2 only. Problem number 2. Limit x tends to infinity x cube by e power x. In this problem, the function is not containing the modulus, not containing the step function. It is not becoming the infinite. It is not given along with the condition for x only. So we cannot use the LHL equal to RHL method. Then we go for other methods. Other method is direct substitution or L'Hospital method. But when you observe this function value at this point, then this will be infinity cube, means infinity, divided by e power infinity, also infinity only. So we are getting the infinity by infinity. This is one of the indeterminate form. Because of this indeterminate form, we try to write the value of this limit by using the L'Hospital method. Let us do this column. Limit extends to infinity of x cube divided by e power x. Limit extends to infinity of x cube derivatives 3x square divided by e power x. Again, it is infinity by infinity. We cannot stop here. Once again, differentiate. Limit extends to infinity of 6x divided by e power x. Still, it is infinity by infinity. Once again, differentiate. 6 by e power x. Now, it is not infinity by infinity, something by infinity form. So we can stop here. This is 0. That's it is the value. Just now I told you that only for 0 by 0, infinity by infinity, we can apply L'Hospital directly. Other forms directly we cannot apply. That is 0 into infinity, infinity minus infinity, 0 power 0, infinity power 0, 1 power infinity. For all these, we cannot apply L'Hospital rule directly. Indirectly, we can apply because all these are reducible to this form only. Now, first we'll discuss how to reduce these forms to 0 by 0 form only or infinity by infinity only. Note point number 1. If limit extends to a of f of x equal to 0, and limit extends to a g of x equal to infinity, then limit extends to a of f of x into g of x equal to. At a point a, this function is becoming 0, this function is becoming infinite. So 0 into infinity. This is in the form of 0 into infinity only. Third form only. Now we try to reduce this to 0 by 0 form. Or we can reduce this to second form infinity by infinity because we can apply L'Hospital rule for any one only. Suppose if you want to reduce this to 0 by 0 form, we should write the f of x into g of x as something by something only. To get the 0 by 0, we require the something by something. F of x is becoming 0, g of x is becoming infinite here at a. But we require 0 by 0. If you want to reduce this to 0 by 0, keep the f of x in the numerator, shift g of x to denominator. That is the adjustment only. Limit extends to a of, keep the f of x in the numerator because we are writing the 0 by 0 form, and shift the other function g of x to denominator. So that will be written as 1 by g of x like this. This is the 0 by 0 form. Next, if you want to write the infinity by infinity, keep the g of x in the numerator and shift f of x to denominator on. This is in the form of infinity by infinity. So it is a method of reduction. Reducing the third form to first form, third form to second form like this. It is a method of reduction. Next, note point number 2. if limit extends to a of f of x equal to infinity and limit extends to a of g of x equal to infinity, then limit extends to a of f of x minus g of x equal to. At a, this is becoming infinite, this is becoming infinite. So this is minus infinity form. Because of this infinity minus infinity is one of the indeterminate form. And we try to reduce this to 0 by 0 form. For this, just like previous one, we make some adjustment and we reduce this to 0 by 0 form. So shift both f of x, g of x to denominator only. That is the adjustment. Limit extends to a of 1 divided by 1 by f of x minus 1 by g of x equal to limit extends to a of 1 by f of x into 1 by g of x. And that 1 by g of x comes to this numerator minus 1 by f of x. Right? Now this is something by something. It is in the form of 0 by 0 only. F of x is becoming infinite and g of x is becoming infinite at a. So 1 by infinity 0, 1 by infinity 0, 1 by infinity 0, 1 by infinity 0, 0 into 0, 0, 0 minus 0, 0. This is 0 by 0 form. 0 by 0 form. Like this, we can reduce the third, fourth to 0 by 0. Similarly, other forms also. Right? Other three forms are like this. 0 power 0, infinity power 0, and 1 power infinity only. Now, these three are in the form of something power something only. Something power something only. Already we know the derivative of sin x. The derivative of sin x is cos x. Derivative of e power x is e power x only. If you want to find the derivative of e power x whole power sin x, then how to find this derivative? We know that derivative of sin x formula, derivative of e power x formula. But we do not know the derivative of this function directly. But we can do the differentiation for this, or we can find the derivative of this only. We can do the derivative. We cannot tell directly, but we can do the derivative of this because already we know the derivative of sin x, derivative of e power x only. This is in the form of some function power function. Some function power some function. If we have a some function power function, to find the derivative of this function, let us consider this as some unknown y, and we take the log on both sides. Log y equal to log of e power x power sin x. This is in the form of log of x power m only. This is same as the m into log x, like that. Here sin x into log of e power x, like this. And we can add the derivative. We can add the derivative on it. Because already we know the derivative of sin x, derivative of log with derivative of e power x on it. Using this, we can add the derivative. Just like this, for these three forms also, we follow the same method on it. Because we can obtain the 0 by 0 power 0, infinity power 0, 1 power infinity. We can obtain these three forms for this type of functions only. We can obtain these three forms for this type of functions. That is why we follow this method only to find the limit of these forms using L'Hospital method. Okay, later we do the problem. First we do the problem on the other form. Okay, problem number 3. Limit extends to pi by 2 of tan x minus secant x. This is not containing, this function is not containing this function is not containing modulus not containing step function, it is not becoming infinite, and it is not given along with the condition for x only. So we cannot go for LHL equal to RHL method, differential method. Then we have other method, direct substitution or L'Hospital. But to apply L'Hospital, one of the independent forms should occur here only. Now we check whether it is possible or not. At pi by 2, tan pi by 2 is becoming infinite. Secant x means 1 by cos. Cos pi by 2, 0, 1 by 0, infinity. This is infinity, this is infinity. So it is in the form of infinity minus infinity form only. Because of this infinity minus infinity, we try to do this problem by L'Hospital method. But L'Hospital is not directly applicable. So let us apply the L'Hospital rule indirectly here on, by reducing this form to other form. Now just now we have written the note point like this. It is infinity minus infinity. We are going back to that page. This page. Page number 41F in this note point number 2 only. Something minus something here. This will be reduced to something by something form. Something minus something to something by something only, right? Now for this, we do like this. We shift f of x to denominator, g of x to denominator. Like that, if you do here, this will be 1 by tan x minus 1 by secant x only. So this 1 by tan x is cot x minus 1 by secant is cos. That's all. And we take the LCM, cot x into cos x, this comes to this goes to this, and then we simplify so that we can do the problem. We get the 0 by 0 form, and then we apply L'Hospital method. This is one method according to this note point 2 only. But we are not doing like this. It is a method only. It is actual method only. But here, see this function. Look at this function. This function is involving the trigonometric functions. Because of trigonometric functions, we express this in terms of sine cos, and easy way we can do the same problem without writing this in this form, without writing the given problem in this form only. In easy way, we do this problem just by expressing these functions in terms of sine and cos only. That is simple method. Actually, this is a method. This is a method only. But here for this problem, we do the same problem in other way only. Limit extends to pi by 2. Tan in terms sine cos is sin x by cos x minus secant is 1 by cos x. This is equal to limit extends to pi by 2 of denominator is same cos x in the numerator sin x minus 1. Now this is the 0 by 0 form. In this way also we can do the problem. But always this may not be possible. Always this may not be possible for every function only. When it is infinity minus infinity only. Possible, we do like this. Not possible, it is a method only. According to note point number 2 only. Okay. So because of 0 by 0, let us do this problem by L'Hospital method. According to L'Hospital method, differentiate numerator and denominator separately. Sin derivative cos x minus 0 divided by minus sin x. At x equal to pi by 2, cos pi by 2, 0, sin pi by 2, 1. This is not 0 by 0. So stop, write the value. This is equal to its value is 0 by minus 1 equal to 0. That's all. It is the answer. Or this method, anyone. So this is about third problem. Next, we go to the problem number 4. Limit extends to infinity of 1 plus x square whole power e power minus x. It is a problem. Again, observe this function. We are given limit of some function. Check the methods on direct substitution or definition method, that is LHL equal RHL method, or L-Hospital method. Check it on. Here, no modulus, no step, it is not becoming infinite, it is not along with the condition for x on m. So, not definition method, that is not LHL equal to RHL method. Maybe direct substitution or L-Hospital method. But here, at infinity, this is becoming e power minus infinity. E power minus infinity is 1 by e power infinity, that is 1 by infinity equal to 0. The power is 0. 1 plus x square whole power e power minus x. This is becoming 0. And x equal to infinity square. Infinity, 1 plus infinity is infinity, infinity power 0. This is in the form of infinity power 0 form. One of the indeterminate form only. Because of one of the indeterminate form, we try to do this problem by L-Hospital method, but indirectly, not directly only. Okay, let us do this problem. And here infinity power 0, this will occur for functions of the form some function whole power function only. If we have a function power function, then we do that. That is, we try to differentiate that type of functions by taking the log. In the same way, here also we do the problem. Let us take the limit of this as some unknown. Let y equal to limit extends to infinity 1 plus x square power e power minus x. So we are assuming the value of this limit as y. Finding the value of the limit is as finding the value of y only. And then take the log on both sides. Log y. I'm writing the log y. In place of base, I did not write anything only. If I do not write anything in the place of base, means it is understood that base e only. But base e means natural item. In general, we should write the ln. Instead of writing the ln, I am writing the log without mentioning the base. That's all. Whenever I write log y without base, means it is understood that log ln y only. So then log of y equal to limit extends to infinity. If you apply the log for this function, this becomes log of 1 plus x square whole power e power minus x. That is e power minus x into log of 1 plus x square, like this. M into log x form. Now this is in the form of is infinity power 0 form. It is in the form of e power minus infinity 0 log infinity. This is infinity 1 plus infinity infinity log infinity infinity. The graph of the log function is like this. When a greater than 1, base is for log function base a is greater than 1 means increasing function. This is y-axis, this is x-axis, this is 0, this is 1, because at 1 log 1 is 0, right? As x increases 0.1, 0.2, 1, 1.1 and so on, as x increases, log function increases. That is why log infinity is infinity only. So this is in the form of 0 into infinity. Zero into infinity form only. The last three forms, that is infinity power 0, infinity power 0, 1 power infinity. 0 power 0, infinity power 0, 1 power infinity. These three forms will be reduced to third form, 0 into infinity. Now we got 0 into infinity. Any one of these form, same method only. That's why we do the one problem always. For 0 into infinity also, we cannot apply L'Hospital directly. Again, we try to reduce this 0 into infinity to 0 by 0 or infinity by infinity only, so that we can write the value by using L'Hospital method only. So which implies log y equal to limit extends to infinity in that I am keeping the log function in the numerator. I am shifting the e power minus x to denominator. When I shift the e power minus x to denominator, then we can add the 1 by e power minus x. Because a negative power, 1 by e power minus x is same as e power x only. So this is e power x. Now this is in the form of infinity by infinity form. Now we got second form. 0 into infinity, third form will be reduced to either 0 by 0 or infinity by infinity. If it is 0 by 0 or infinity by infinity, we can apply the L'Hospital method only. Which implies log y equal to limit extends to infinity. According to L'Hospital, differentiate numerator separately, denominator separately. Log derivative is 1 by 1 plus x square. One by 1 plus x square. Again 1 plus x square derivatives, inner function derivatives 2x divided by e power x derivatives e power x. This is equal to limit extends to infinity 2x divided by 1 plus x square into e power x. Now this is in the form of again infinity by infinity only. Because of this, once again we differentiate only. Log y equal to limit extends to infinity 2x derivative 2 in the denominator product of two functions 1 plus x square into e power x derivative e power x plus 1 plus x square derivative is 2x into e power x. This is not in the form of 0, not in the form of infinity by infinity, something by infinity only. This is equal to something by infinity. So we can stop here. Something by infinity is 0, which implies log y equal to 0. Therefore, y equal to e power 0. This is equal to 1. But the value of y is same as value of the given limit. That's it. It is a method. So same procedure for these three forms only 0 power 0, infinity power 0, 1 power infinity. All three forms will be reduced to third form to either first or second only. It is the same method for all. Okay, we write another problem. Problem number 5. Limit extends to 0 of x power x. No modulus, no step, no condition for x. So no modulus, therefore it is not in the form of LHL equal to RHL method only. That is, we cannot do this by LHL equal to RHL definition method only, actual method only. Next, we check whether it is direct substitution method or whether it is L'Hospital method only. When you substitute x equal 0 here, we get a 0 power 0. 0 power 0. Because of 0 power 0, it is one of the indeterminate form. That is why we do this problem by L'Hospital method, but indirectly because of the 0 power 0 only. Like previous problem. The previous problem is like this. Limit extends to infinity 1 plus x square power e power minus x only. It is in the form of infinity power 0 only. So if it is infinity power 0, 0 power 0 or 1 power infinity, same method only. These three will be reduced to third form 0 into infinity. Again third form to either 0 by 0 form or infinity by infinity, like this. That is a method. Okay. So we can do this problem by the previous problem method. Now before going to do this problem, just observe this previous problem function and this problem function. Just look at both functions. You can find some observation from these two only. What is the observation? Now, the difference is, look at this. Function of x, power function of x. Function of x, power function of x. The difference is, in the previous problem, base function and power functions are different. In the present problem, base function, power functions are same. Both base and power are same. Power function is x, base function is x. Both functions are same. Here, both functions are different. It is a main difference, right? Now here, I am not doing this problem by like previous problem method. I am doing this problem with one shortcut method only. If any problem is like this, if limit extends to a of f of x equal to 0, then limit extends to a of f of x power f of x equal to 1. Using this formula, directly we get the value of this one. It is direct shortcut formula. Otherwise, if you do not know this, we can do this problem like previous problem method only. F of x power f of x. F of x equal to x. And if you substitute this a equal to 0 in this f of x, that becomes 0 only. That is why we can get the value of this directly only. Therefore, limit extends to 0 of x power x equal to 1. Since limit extends to 0 of f of x. Here f of x is x equal to 0. Directly we can write this value on. So if a function is in the form of function power function, also base function power functions are same, and this condition satisfies, then we can add the value as 1 directly only. Right? So with this, problems on indeterminate forms are completed only. With this, total differential calculus part is completed. In the differential calculus, we have seen limits, continuity, differentiability, mean value theorems, partial and total derivatives, Taylor-Maclaurin series, and maximum only. At the end, we have done the problems on indeterminate forms. With this, the differential calculus part is completed. Next, we go to the other part, integral calculus only. So our continuation subtopics. Next topic is definite integrals only. definite integrals. Onwards, we start integral calculus part. Just write the heading. If you want to write heading, then stop. Just look at this. F of x interval and integral of f of x dx equal to capital F of x. Now here, the two conditions. One condition is f of x should be continuous on this interval. F of x should be continuous on this interval, and the integral of this function should be capital F of x. Then we can write this value, and this value is we can write this value using this function, using this interval only. And this value is the definite value of this integral. This value is the definite value of the integral only. Therefore, we write this as integral x equal to a to b f of x dx equal to f of x from a to b equal to f of b minus f of a only. It is a definite value of the integral, and this integral is definite integral. Here, a is the lower limit of the integral, b is the upper limit of the integral, and this x is the variable of integral. This x is the variable of integral. My side voice is okay, and check your voice, your instrumental. Now okay, audible for all or only some people? Is it fine? Are you able to hear my voice? Yes, all are saying that yes. Okay, let us continue this. Now, the function is continuous in the interval, and the integral of this function is capital F of x. These two are possible. Then we write the value of the integral by using this function interval on. And this value is the definite value of the integral. And we write this integral as like this. This a is called lower limit, b is called upper limit of the integral, and this x is the variable of integral. Variable of integral. If we have y, then y is the variable of integral. If it is x, variable of integral. Here this function f of x is called integrand function. Integrand function, right? So this is about definite integral. Here two conditions. Function should be continuous and the integral of the function should be capital F of x. That is, integration is possible and the function is continuous. Then we write the value. Otherwise, we cannot write value. For example, integral 0 to pi by 2 sin x dx. The function f of x is sin x only. Interval is 0, pi by 2. Sin x is continuous or not? Check it out. We can tell it directly continuous or not only. Because sin x is standard function, one of the standard function only. Because of the standard function, sin x is continuous for all the values of x. You take any interval, in every interval, the function will be continuous. So in the particular interval 0, pi by 2, also sin x is, in the particular interval 0 to pi by 2, sin x is continuous. So one condition is satisfied. This condition is satisfied, continuity condition. Next, is it possible? We check it only. Integral of sin x is minus cos x. Integral of sin x is minus cos x. From 0 to pi. That is, integration is possible. This second condition is also satisfied. This integration is possible. Function is continuous and the integration is possible. That is why we can add the value of the integral. Such a value is the definite integral. Cos pi by 2 minus cos 0. This is the definite value of the integral. Now let us take the another example. 0 to pi by 2 e power minus x square dx. First of all, this minus x square is continuous. E power minus x square is also continuous because function of function. E power x, in place of x, we have some other function minus x square only. So minus x square is continuous. E power minus x square is continuous. Function of function, composite function. Now this is continuous for all the values of x. In the interval 0, pi by 2, also function is continuous only. Right? Now this condition is satisfied. One of the conditions satisfied here. This is satisfied. Check second condition satisfies or not. What is the integral of e power minus x square? Now tell me the integral of e power minus x square. What is the integral of e power minus x square? Okay, leave it. Let us observe this. Integral of e power ax is integral of e power ax dx is e power ax by a. Integral of x e power x dx equal to x into e power x minus e power x. X e power x square dx equal to 1 by 2 into 2x into e power x square dx equal to 1 by 2 into e power x square. Like that. What is the integral of e power x square or the e power minus x square dx? What is the integral of this? What is the integral of this? We know the integral of e power ax. We know the integral of x into e power x. We know the integral of x into e power x square. But integral of e power minus x square dx is not possible. We cannot find the integral of this. We have a method for the evaluation of this, method of evaluation of this, method of evaluation of this. But for this, we don't have the method of evaluation of integral. So from this, we can set all functions may not be integrable. All functions may not be integrable. We have very few limited methods for the evaluation of integral. We have very few limited methods for the evaluation of integrals. That is why all functions may not be integrable. The method is available, we can add the integral of the function. If the integration is possible, we can add the solution of the differential equation also. That is why I told that one point in the differential equation topic. The note point is all differential equations cannot be solved. All differential equations cannot be solved because all functions cannot be integrable. We have very few limited methods. The method is available, we can add the integral of the function. Randomly, if we write some function, we may or may not integrate only. Because method is possible, we can add the integral. We can add the integral. Method is not available, we cannot write the integral. So integration is possible, integration is possible, integration is possible. Here integration is not possible. Integral of e power x is e power x square also not possible only. So in this case, the second condition is failed. This is satisfied, continuous only. This condition is failed. That is, this f of x, capital F of x is not possible. Therefore, this is not possible. That's all. That is why this value is not possible here only. When function is continuous and the integration of this function is possible, then we can add this value. Otherwise, we cannot write value only. But here, we can write the approximate value. If you are unable to integrate this function, then we can add the approximate value of this integral by using numerical methods. If you are unable to integrate this, then we can add the approximate value of the integral using numerical methods. In the numerical methods, we have the trapezoidal rule, Simpson's 1/3 rule, Simpson's 3/8 rule, Boole's rule, Wedel's rule, like this. Using these methods, we can add the approximate value of the integral on it. Right? So in general, integral a to b f of x dx equal to f of b minus f of a on it. This is the definite integral on it. It is the definite value of the integral. Next, geometrically, this value is the area under the curve above the x-axis between two lines only. This f of x is the function of one variable. Geometrically, it represents a curve. X equal to a, x equal to b. This region, area, this region is bounded by the curve y equal to f of x, the lines x equal to b, and the x-axis only. The area of this region is given by the integral a to b f of x dx only. Geometrically, its value is the area of the plane region. This is about definite integral. But here, we try to write the value of the definite integral in easy way by using some properties only. If you know the properties, we can write the value of the integral in easy way only. Or using the properties, we can shorten the calculation. So let us write the properties of definite integral, and then we do the problems on this. Properties of definite integrals. We write all the properties. We have many properties, but we write the important properties. Frequently, we use the properties only. Whatever we use frequently, we write all those properties only, which are very, very important. Because based on this, we have the gate questions, and also you may get questions in future also. Okay, let us start first property. Integral f of x dx equal to minus integral b to a f of x dx. That is, if you want to interchange the limits, then we should write the minus like this. On left hand side, the integral limits are a to b only. And right hand side, the integral limits are b to a. If we change the limits, then we should write the minus sum. Or already if we have a minus, then we substitute first lower limit and then upper limit. Because for right hand side, lower limit is same as left hand side, it is upper limit. Second property, integral if a less than c less than b, then integral a to b f of x dx equal to integral a to c f of x dx plus integral c to b f of x dx, right? That is on the line, on the real line, within the interval a comma b, we have taken some point c somewhere. If we choose some point c somewhere between a and b, then we can divide the interval into two parts. It is c only. That is a to c one interval and c to b one interval. That is how we can write the integral a to b as a to c, c to b only. A to b is same as the a to c plus c to b, like this only. So if you take one point, then we write the sum of the two integrals only. If you take one more point here, d, then we write the integral as sum of the three integrals. 1, 2, 3 integral. A to c, c to d, d to b, like this. 1 point, 2 integrals, 2 points, 3 integrals, n points, n plus 1 integrals only within the interval only. Next, property number 3, integral a to b f of x dx equal to integral a to b f of a plus b minus x dx. Just by looking the definite integral problem or definite integral question, if you are unable to identify the method, just by looking the problem, if you are unable to identify the method, then in such case we try to apply this property number 3 only. So this plays an important role in the definite integral problems. This property plays an important role. If you are unable to identify the method depending on the problem or just by looking the problem, in such case we try to do the problem by using this property number 3. According to this property, if this is a given integral, from this we can add one more integral like this, because a to b same, dx is same. Only in place of x, the difference is a plus b minus x only. That is, the value of this integral is equal to value of this integral only. That is, we generate the new integral from this given, and with the help of the new integral possible to evaluate, we can evaluate. Right? Next, and the same property, integral a to b something by something f of x divided by f of x plus f of a plus b minus x dx equal to b minus a by 2 only. This result is obtained from this property number 3 only. So in the given problem, if any function is in the form of like this, directly we can add the value of the integral only. Just b minus a by 2 only. For example, 0 to 2 root x by root x plus 2 minus x dx. The problem is given like this, something by something. And here, when you observe the total function, these two functions are same. So if this is f of x, this is f of x only. Then we check this total function is in the form of like this or not. The total function is like this, directly we can add its value only. That is, here, if we get this function using this variable, then this will satisfy, then we get the value of this only. Can you get this function from this function or not? Here, f of x equal to root x. Then f of a plus b minus x, 0 plus 2 minus x equal to. 2 minus x. We are getting this. Therefore, we can add the value of this. That is 2 minus 0 by 2. That's it is the answer. According to this result on standard result. And this result is obtained from this property onwards. Okay. Next, property number 4. Integral 0 to a f of x dx equal to integral 0 to a f of a minus x dx. We can add this from the previous just by substituting a equal to 0, b equal to a. In place of a, 0, in place of b, a. Then 3 becomes 4 like this. We can add the 4 from 3 for a equal to 0 and b equal to a. Both are same one. It is particular interval 0 to a, it is any interval a comma b on. Next, property number 5. Integral minus a to plus a f of x dx equal to. Here, if observe limits, both limits are same, a, but opposite sign. This is minus, this is plus only. If we have a limits like this, then we write this integral in 2 ways, depending on the function f of x. 2 times integral 0 to a f of x dx. If f of x is an even function. The condition for even function is f of minus x equal to plus f of x. It is a condition for even function. Next, 0 if f of x is an odd function. The condition for odd function is f of minus x equal to minus f of x. This is for even. It is a condition for odd function. So whenever the limits are minus a 2 plus a, that is minus 2 plus 2 minus l 2 plus l form, then we check the function is even or odd. Otherwise, we never check even or odd. Sixth one. Integral 0 to a f of x dx. So we try to write this integral also in 2 ways, just like above. Just like above, we write 2 ways. Two times integral 0 to a by 2 f of x dx. If f of a minus x equal to plus f of x, 0. If f of a minus x equal to minus f of x. Like above, we write this integral in 2 ways depending on the condition. F of a minus x equal to plus f of x 2 times 0 to a by 2. F of a minus x equal to minus f of x. F of a minus x equal to minus f of x, then 0. Next, 7th one. Integral 0 to a x into f of x dx equal to a by 2 into integral 0 to a f of x dx. If f of a minus x equal to plus f of x. Like above, the condition. Now look at this left right only of this property. Left hand side is x into f of x. Right hand side is just f of x only. If we have a product like this x into f of x, we can reduce the product to single function f of x. That is, we can eliminate x. We can add only f of x here with the condition, this condition on. So this condition satisfies for this function f of x. We can reduce this product to single function and read the a by 2 to this. This is property number 7. Next, property number 8. Integral 0 to pi by 2 sine power n of x dx equal to integral 0 to pi by 2 cos power n of x dx. So for these two, same value on 0 to pi by 2, 0 to pi by 2, sine power n or cos power n. For both, the value is same. That is the same way we write the value of this integral. How its value is given by like this, something by something. We write the something in the numerator, we write something in the denominator. Using the power, we write like this. First, we start with the n minus 1 in the numerator. In the denominator, n minus 0. That is power minus 1, power minus 0. And then decrease by 2, decrease by 2. N minus 1, decrease by 2 means minus 2, minus 2, minus 2 like this one. N minus 1, minus 2, that is n minus 3. N minus 3, minus 2, n minus 5, and so on like this one. N minus 0. In the denominator, we are writing the power minus 0. In the numerator, we are starting with the power minus 1. It is only difference. And then decrease by 2, 2, 2 like this only. N minus 0, minus 2, n minus 2, n minus 2, minus 2, n minus 4, and so on like this. Into k, comma, where k equal to pi by 2 or 1. If n is an even integer, n is an even integer. If n is an odd integer. And also this n should be natural number. This property or this standard integral works only for positive integer powers. That is why, and small n belongs to capital N. Small n belongs to capital N. Capital N means set of all natural numbers only. This property works only for positive integer powers. That is 2, 3, 4, 5, 6 like this only. Not for fractions, not for negative numbers, not for rational numbers like this only. So we have some special integral formula, that is beta gamma function, beta function, gamma function. These two are special functions. Using that, you can write the value of this type of integrals when n is not an integer also. But here, this is only for positive integer powers. Next, 9th one. Integral 0 to pi by 2 sine power m of x into cos power n of x dx equal to. Again, like above, we read the something by something, just like same method. Okay, before writing this formula, let us look at the previous one, 8th property. Suppose in place of n equal to 7, for 8th property, in place of n equal to 7, then in the numerator start with a 7 minus 1, in the denominator start with a 7 minus 0, like this one. Let us suppose n equal to 7, sine power 7, cos power 7, then write the like this only. Power minus 1 in the denominator power minus 0, and then decrease by 2. 7 minus 1 minus 2, 7 minus 3, next 7 minus 5, 7 minus, next will be 7. Here 7 minus 0, 7 minus 2, 7 minus 4, 7 minus 6, 7 minus 8. Now here the condition is this. We continue this process until one condition is satisfied. The condition is here, this number and so on like this here, 1, 3, 5. This number n should not be same as this and should not be less than this. Okay. N equal to 7 here, right? But here it is same as this number. N equal to 7 is same as this number. That is why we should not write this. Next here, this number n should not be same as 4. This number should not be less than this number only, right? N should not be same as this number, and also n should not be this. N should be more than this 4. N should be more than 5. With that condition, continue like this. See this here. If n equal to 7, 7 minus 1, 7 minus 3, 7 minus 5, that is 7 greater than 1. Here 7 is greater than 1, 7 is greater than 3, 7 is greater than 5. But here 7 is same as 7. That is why I should not write this. Stop here. Here 7 is more than this, 7 is more than this, 7 is more than this, 7 is more than this. Here 7 is not more than this, 7 is less than this. That's why don't write this on. Stop here. So always n should be more than this number. N should be more than this number only. Should not be same as this, should not be same as this, should not be less than this. N should be more than this. With that condition, we continue like this. The same thing for next property also. Okay, let us write the property like above only. First, we start with the power m. In the numerator, start with the power m minus 1, decrease by 2, m minus 3, m minus 5, and so on. But what is the condition here? M should not be same as 5, m should not be less than 5, m should be more than 5, like that. With that condition, we can say. So we can do this until this is more than this only. Should not be same, should not be less than this only. M should not be less than 5 only. Next, into n. N minus 1, n minus 3, into n minus 5, and so on. Same condition. N is always more than this 5, like this one. Next is n minus 7, and so on. N should be more than 7, like this one. In the denominator, sum of the two powers, m plus n minus 0, and decrease by 2 only. That's it. Into k, comma, where k equal to pi by 2, here 1, if m and n are even integers. If here otherwise. And m comma n belongs to capital N. Within 5 minutes, we close this. Now, this is the 9th property on. Both m, n are even integers, then we write the pi by 2. Otherwise, 1. Otherwise means anyone is odd, both are odd, then 1 only. Next, property number 10. Integral u v dx equal to, it is the integration by parts formula. Let us take this as first function, this as second function. We will take the first and second function according to I late from left to right order. E stands for exponential, T stands for trigonometric, A stands for algebraic, L stands for logarithmic, I stands for inverse trigonometric functions. First function into integral of second function minus inside the integral first function derivative into integral of second function, again whole function dx only. This is u dash. Next, 11th one. 11th one is also integration by parts formula, but generalization of this one. Integral of u v dx equal to u into v1 v suffix 1 minus u dash into v suffix 2 plus u double dash into v suffix 3 minus u triple dash into v suffix 4 plus and so on like this. Here, where dash denotes differentiation and suffix denotes integration. It is a generalization of this above integration by parts formula. But to apply this one, this should be polynomial function. It is a first function. This function should be polynomial. Otherwise, this process will not stop only. It's a condition. To apply this generalized integration by parts formula, the first function should be polynomial function. Otherwise, we cannot apply this one because this process will not stop. It will be continued only. Next, 12th one. Only two more are there. d by dx of integral of f of x dx. Well, it is f of x. Derivative of integral is just f of x only. Because derivative integral will get cancelled directly with the same function f of x. Next, 13th. d by dx of integral u of x to v of x f of x dx equal to d by dx of v of x into f of v of x minus d by dx of u of x into f of u of x. Remember this just like upper limit minus lower limit form. Derivative of v of x into v of x inside the function minus derivative of u of x into inside the function u of x. That is just like upper limit minus lower limit form. Upper limit minus lower limit form. Remember like this form. That's all. These are the properties. So with this, I close the session, today's session. We continue this in the next class. Next, we start the doubt session. Hello? Hello?
Hello.
Ask your doubt.
Good evening, sir.
Good afternoon. Tell me.
Sir, actually, how 1 to the power infinity is
1 power infinity is to 0 by 0 form. Hello?
no, sir. Why? How 1 to the power infinity is an indeterminate form?
Anything is reducible to 0 by 0 form, then such a form is called indeterminate form. That's directly. Because here, infinity by infinity
Yes,
0
sir.
into infinity,
Yes, sir.
infinity plus infinity, 0 power 0, infinity power 0, and 1 power infinity. All these will be reduced to this 0 by 0. That is why all these are indeterminate forms.
Yes, sir.
Even that is 1 power infinity also, we can reduce this to 0 by 0. Because these forms will be possible for this type of functions, f of x power g of x. And if you take the log on both sides, if it reduce this into 0 by 0. Okay. Hello.
Sir, can you just derive that to 1 to the power infinity to
1 power infinity. Same form. Whatever we had done the problem. We
yes,
have
sir. Yes, sir.
same method. You would take some problem with the 1 power infinity, and if you do that, we get the 0 by 0. See this. These three will be reduced to directly third form, 0 to 0 infinity to either 0 by 0 or infinity by infinity only. Even though it is infinity by infinity, again this is to 0 by 0. That's all. It is a method. And we had done one problem, 1 plus x square.
Okay.
Same way. You take one of the problem with this 1 power infinity, we get same thing only.
Okay. 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 Okay, sir.
Limit extends to 0.
Okay.
1 plus x limit. So 1 power infinity. Now, series. If you substitute 0, here 0.
Yes, sir. Yes, sir.
Okay. And you take this log, apply log. If you do like that, at the end we get this form.
Okay.
Okay.
Okay. Okay. Okay. Okay, sir. Okay. Okay. Thank you.
Hello.
Hello, good evening, sir.
Good evening. Tell me what.
Sir, in one question of maximum area of square units in ellipse,
Yeah.
in that question, how a square is also maximum, sir?
Let us suppose a is the maximum value. The maximum value is 2. If I
Yes.
square it, correct or not? It is also maximum.
Okay, like if we substitute this value, then we will get maximum value only, sir.
Already we know that 2 is the maximum value. If we square it also, we are getting more than this only. Maximum.
Okay, sir. If we divide also, it is maximum, sir.
Whether it is, if you divide this one, suppose if you take 1 by a square, that is 1 by 2 square. 1 by 4 means not more than is 2. So this is not maximum. It is minimum only. Denominator increases, this becomes minimum only. This is increasing means this also increases. That is the maximum.
Okay, 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 sir. Okay, sir. And sir, actually, if we get indeterminate form, we will use L'Hospital rule, right, sir?
Yeah.
Sir, I'm not getting the significance, sir. Actually, what it is happening there, sir? Like,
Actually,
we are
getting meaningless form, 0 by 0 like this, meaningless form only. So in such case, we cannot write the particular definite value only.
yes, sir.
So
If we differentiate numerator and denominator, then the value will reduce its area, sir.
no, not like that. You don't combine this one only. Just by making use of the derivative, we are writing the value of this. Actually, it is indeterminate form. We are making it determinate form only. That is, we are making the meaningless to meaningful form only with the help of the derivative only.
Yes, sir. That I got it, sir. Like, what's actually it is like, if we differentiate, then the large value will be reduced to small, like that. It will be, sir.
Yeah, approaching value.
Approaching, then it will be finite.
Yeah.
Okay, okay, sir. And sir, in properties of definite integrals, third property, sir. How we get that, sir?
A to b f of x dx equal to integral a to b f of a plus b plus minus x, right?
Yes, sir.
Take this one. Let us take the a plus b minus x with some other variable y and do the substitution method. If we do like this, again we get this formula. Take this RHS part. Okay.
Okay, sir.
Integral. And to prove this RHS equal to LHS, in place of this a plus b minus x, we require only single variable x only. So I'm taking the a plus b minus x equal to y.
Yes, sir.
Minus dx equal to dy. Then limits here f of y minus dy like this, and put a plus b minus x equal to y. We require the y limits only.
Yes,
So
sir.
lower limit x equal to a. When you substitute x equal to a, what do you get here? These two get cancelled. Y equal to b. This is b. When you substitute upper limit to b in place of x, these two get cancelled. A. Right?
Okay, okay. That negative will change the limit to b, a to b. Okay. And the last property, sir, if u and v are the functions, then we can integrate in that form, sir.
U and V are functions. Last property or 12th
No,
property?
sir. In last property, limits are u of x means a function of x, sir.
Function of x. V of x and U of x, not constants.
Like x square plus 2, like that.
Any one may be constant, but one of the two limits should be function of x.
It might be any function, sir. Sin x.
Any function, sine or cos or x square, something, any function, but should be function of x. So out of u and v, one of the function should be function of x. Both should not be constant. Any one may be constant.
Okay, okay, sir. Okay. Thank you, sir.